Now I want to tell you about the function of lungs in different types of vertebrates, beginning with amphibians. Amphibians are going to conduct the process of ventilating. Ventilating means taking air in and then exhaling, taking the air out. They are going to have alternate inhalation and exhalation. But take a look at how they do it in a manner that is different from how other vertebrates do it, like you and I. In amphibians, there's going to be a space in the mouth, which will be the same as you, like just taking air into your mouth. And then they close the mouth, and what they do is through the action of muscle contractions, collapsing the palate, which is the ceiling of the mouth, and the bottom of the mouth, where the tongue is going to be, by collapsing that, they are going to end up pushing air from the mouth. Having trouble controlling here. So air is going to be pushed from the mouth over to where the lungs are going to be. And for those of you who may not be too proud of things we've done before, when we were younger, when we were teenagers, sometimes you can do that yourself. You can actually take air in your mouth and gulp it down into your stomach and then push it out. That belching, yes, it's nothing to be proud about. But if you understand what I'm talking about, that is similar to the way that frogs and toads are going to be breathing, except their air is not moving to the stomach. It's going to be moving to the lungs. Because the air is being pushed into the lungs, this is going to be called positive pressure. When air is being blown into the lungs forcefully by the contraction of muscles that are collapsing the mouth, and that's how air goes in. So that is going to be different from how other animals are going to be breathing. Let's take a look at animal breathing in the case of birds. Now, birds need high amounts of oxygen. Well, we know that endothermy, the need for using energy to generate heat to maintain internal temperature conditions that are steady, will require a lot of energy. And so with energy processing also comes the need for oxygen. But in addition to endothermy, in addition to animals generating their own heat, birds are going to be capable of performing like some of the most amazing migrations. I mean, a bird can be in the air flying, flapping the wings for hours and hours and hours, sometimes even a day without pausing to rest until they eventually find a place where they can refuel or just get some rest. So take a look at the way in which birds accomplish breathing. There are going to be 4 events. First is going to be the first inhalation. Air comes into the nostrils and it moves into what we call the posterior sacs. That's the first inhalation. Air filling the posterior sacs. The next event comes the first exhalation. But when the first exhalation happens, air doesn't go out of the body of the animal. Air simply is now moved to the lungs. So notice that air first went into the posterior air sacs, and during exhalation, air moves out of the posterior air sacs, and over to the lungs. Then the next step is going to be the second inhalation. In the second inhalation, air from the lungs moves into the anterior air sacs near the head of the animal. And the fourth step is going to be exhalation, the second exhalation, which is air moving from the anterior air sacs out of the body of the animal. What one must keep in mind here is that at the time the first exhalation is happening from posterior air sacs to lungs, the next round, the next cycle of inhalations will be taking place. And so here's another way to look at it, and this is so ingenious, this is so fantastic. Every time the bird does the second exhalation, at the same time it's blowing air out, a new round of first inhalation is coming in. So Birds can do this. Don't try this at home. Don't try to figure, because with us, there's no way, there's no possible way you can like take air out and in at the same time. It just doesn't function that way. The reason it works with birds is because they have these posterior and anterior air sacs, and they have lungs that are going to be separated from that. And so every time the bird is inhaling or exhaling, there's going to be a fresh flow of air providing oxygen to the lungs. So think about it one more time. Here's what I'm saying. Inhaling and exhaling, it doesn't matter. Every time air is passing through the lungs, bringing a fresh supply of oxygen. Now, I wish I was a bird. I wish I could have this kind of a breathing so my running would improve. But no, I continue to be the slow runner I am. And for me, really, it's not my legs that get tired. It's just that the oxygen. I feel like I run out of oxygen. So I have to slow down just to catch my breath. All right. So remember, the breathing of birds is going to have 4 steps. There's going to be 4 events. There's going to be 2 inhalations and 2 exhalations. For you and I, what we use is going to be our mammalian style of breathing, which is going to include the ventilating of the lungs through the action of muscle activity. And that's what I want to describe to you now. So every time you're going to breathe in, there are going to be 2 sets of muscles that are going to be at work. One is going to be the diaphragm, and you can see an illustration of the diaphragm at the bottom of your rib cage. Perhaps I can enlarge this illustration so you can see better what I'm talking about. So when you're about to take air in, before air goes in, look, this is important. Before air goes in, the diaphragm contracts, lowering your rib, compartment is going to be basically pulling down all of this part of your chest cavity. But muscles associated with your ribs are also going to be pulling your rib cage up. So it's like, imagine you're taking something that is collapsing your hands, and you're like moving your hands apart. What's happening in the space there between your hands is going to be increasing. And so that is what is going to happen to the lungs. The volume of the lungs is going to increase. So check out 3 steps here. First, contraction of the diaphragm and muscles of your rib cage. After that contraction, step 2, the volume of the lungs is going to increase. And then, finally, step 3, air is going to be drawn into the lungs by negative pressure. I like an analogy that is presented in the textbook. Have you ever played with a syringe? So you can shoot like water. We sometimes get silly in lab. When I was in undergrad school, we'll take a syringe and we'll just fill it up with water and just shoot your lab mates with water. So whenever you are pulling on the plunger of the syringe, that creates a negative pressure. The pulling of the plunger is like when your diaphragm is moving down. That creates a negative pressure inside of the chamber, inside of the syringe, and that draws a liquid in or air in. And that's exactly what happens with your lungs. The contraction of muscles, second, increases lung volume, and number 3, air goes in, drawn by negative pressure. And so in terms of breathing and the amount of air that goes in, doctors sometimes use tidal volume. The tidal volume is simply you resting in a resting state, just breathing in and out. And if you can focus for a moment, just breathe normally. That is going to be your tidal volume. Your vital capacity will be like when a doctor says to you, okay, now take a deep breath. And you inflate your lungs as much as you can. The maximum you can hold, that is going to be your vital capacity. It's the maximum tidal volume, the maximum air you can breathe in is going to be the vital capacity. When you exhale, there is always going to be a small amount of air remaining in your lungs, and that is going to be the residual volume. How do you know you have it? Again, just focus for a couple of seconds on your breathing. Breathe in, breathe out. Now, before you breathe in again, hold your breath, contract your chest cavity, and blow more air out. And you can do that. And so that air that remains, and you are usually not pushing it out, that is going to be the residual volume, the air that remains in the lungs. There are going to be other descriptions in your textbook talking about adaptations for animals that deal with diving. Check those out. Read that section that deals with myoglobin, that deals with what animals do when they are diving, how they restrict flow of blood to muscles, but do provide oxygen, providing blood with oxygen to the brain and to the spinal cord. That is going to be definitely interesting reading too, and I recommend you check it out. And that's all for right now.